Hey, hey! What does an acorn say when it grows up? Geometry. Get it? Geometry. Well, we're gonna keep doing some geometry today, talking about transformations. And in this lesson, we're gonna continue the idea of looking at the different types of transformations and what happens to them after a transformation occurs. But in this lesson, we're gonna specifically look a little bit closer at reflections. So let's look at the problem to start off, and this is in your notes on page 178. So make sure you're open to page 178. The problem says in the diagram below, triangle ZWO is congruent. Remember, that's a congruent symbol to triangle YXO. Describe the transformation that transforms triangle ZYO to triangle YXO. Now, if you look at it, you can see it looks like a mirror image, a red mirror image of it. And if you were to describe the transformation, you could say that, hey, I know it's a reflection going on this line. So if I would describe that, I would say reflection. But for purpose of describing and having a good description, it's always great to have more description to it. So it's a reflection, and as we've been talking about, creates a congruent figure. All the parts are congruent. We'll say a congruent triangle. So all the parts are congruent. It also changes the coordinates. So that's another thing that we're going to look at in this problem itself. So how else could you describe that transformation? So let's look down at your notes underneath there. There's a couple examples of other ways you could describe it. You could specifically look at the coordinates. So we're talking about the coordinates. The original coordinates were negative 4, 0. So negative 4, 0 right here. It's coordinate Z. Negative 4, 2, so that was W. And then 0, 0 was our third point. Now on our new graph, we end up with 0, 0 as one of them, but then it goes to 4, 0 and 4, 2. So you might notice it has the same numbers except one slight change. What is that change? Maybe you can tell it's just the x value, the front value, just became the opposite. Went from negative 4 to positive 4. Now can you tell what we reflected over? What was the line of reflection? It happened to be that y-axis. So there's some special things that happens if you reflect over the x or y-axis. In this case, over the y-axis, the only thing that would change is the sign on the x value. And maybe you can take a guess, if you go over the x-axis, it'll be the opposite. You would change the sign on the y value. So in words, you can also say z is transformed to y, w is transformed to x, o is transformed to itself because it ends up not moving when it reflects over that line because it's already on the line. So that's the idea of a reflection here. Let's talk about a couple of the questions in your book. Go to question number 7. What kind of a transformation is used to transform ZWO to X or YXO? Okay, hopefully you already answered that. But make sure you have an explanation. It is a reflection. How do you know it's a reflection? Because all points are the same distance away from the y-axis. And the y-axis happens to be our line of reflection. And in other words, it mirrored. All right, question number 8, right? Right, and then compare the coordinate pairs for the corresponding vertices. So for Z, point Z, if you look back, Z, we said the point was negative 4, 0, and it transformed to 4, 0. So negative 4, 0, 4, 0. W was negative 4, 2, and then it went to 4, 2. So how does your answer to problem 8 fit with the locations of vertices on the original figure and its reflection image? So what changed and what didn't change? Really, they're same spot on the grid vertically, but horizontally they changed. So they're opposite sides of the y-axis. So that's what I would say is the best descriptor, opposite sides of the y-axis. If you're looking at the location, but if you're looking at the actual values, what changed? It was the x value, so opposite x values. So we're going to say comma opposite x values. Just looking at these patterns, you notice there's similarities, there's differences. We looked at it yesterday with rotations too. When you do 180 degrees, it just made all the values the opposite. So if it was a negative, it was a positive, positive, negative. It didn't change the order or anything like that. For 180 degrees, it just changed and made everything the opposite. So number 10, how does the reflection of a figure over the y-axis change the coordinates of the vertices? Well, the coordinates don't change, but the x values become the opposites. Now again, follow-up question would be, how does the reflection figure over the y-axis or the x-axis change? It would just be the opposite. The coordinates don't change, but the y values would actually be the opposites. And you can test that out on a graph as well. These are just some unique patterns, some unique relationships we see with coordinates when you do, in this case, reflections. So I'd like you guys to finish with numbers 11 and 12. I'd like you to try numbers 11 and 12. 11 is dealing with a translation. We're going to look at things that changed, and 12, well, finding actually what the unique changes there. So why don't you pause the video and try 11 and 12. All right, so hopefully you were able to look at the originals. It was the Z, W, and O was -4, 0, -4, 2, and 0, 0. We're using the same triangle as before, and I put it on the graph there in blue. What it's asking you to do is take it and move it 2 units to the right and 1 unit up. So that's a translation. And we're going to label it as Z prime, W prime, and O prime. So 2 units to the right. Make sure when you're doing this, 2 units to the right and 1 unit up, you do that to all 3 coordinates. So if I take W, for instance, and I move 2 units to the right and 1 unit up, it should end up right on that point. So that would be W prime right here. 2 units to the right and 1 unit up. And that point is -2 and 3. Well, that was for W. Whoops. Gotta move those. Alright. What if I do the same thing with Z? I take it 2 units to the right and 1 unit up. My point should end up right there at -2, 1. So that would be my new Z prime. -2, 1. And my O would go 2 to the right and 1 unit up. And that would give me the point 2, 1. So right here, 2, 1 would be O prime. So I got my new triangle right there. And again, you should notice it's the same shape, same size. It just moved a little bit. So to 2, 1. So specifically compare the coordinates. What do you notice is different about the x values and the y values? So look at all the x values. We went from -4 to -2. We went from -4 to -2. We went from 0 to 2. Do you notice anything about all 3 of those, about how they changed? They all went up 2. So it was +2. And if we look at the y values, It went from 0 to 1, from 2 to 3, and from 0 to 1. What do you notice changed with all of the y values? They were all up 1. And that is where the notation that we've been talking about each day comes into play. The x values were plus 2. The y values were plus 1 when you go right and up. All right. There's our lesson for 19.3. Sorry, this is talking about comparing coordinates, whether it's a reflection, translation, whatever it may be. We're comparing coordinates and seeing how they would change. But again, the size and shape stay the same. All right. There it is. Have a great rest of your day.